Welcome to Mechanical Tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to explain about deep groove ball bearing with a top-down approach. So these are the components: outer ring, inner ring, ball, rivet and retainer, or sometimes it is called as a cage. See, this is the assembly of ball bearing. So this is the cage, ball, outer ring and inner ring. The small component is rivet. So I am going to show you how to retrieve the standard component from the toolbox. See, here I am going to show you how to create this retainer with two different methods. One is using a shell and the other using with a surface. And I am going to explain easy method with top-down approach. See, here I am going to use this simple sketch as a design reference. The outer dia of the outer ring and inner dia of the inner ring and width of the bearing and diameter of the ball. So using this sketch I am going to create all these components in a single assembly. So let's start now. Initially I am going to create outer ring. See, we have to take a new assembly file. So I have taken already a new assembly file. Now we have to create this sketch in the assembly. Here we have to select the right plane, go to sketch, select a corner rectangle, of two sketches. Now draw one center line. So 25 mm. So this is the width of the bearing. Here we have to select this line, right click and select the midpoint, select the origin and make it vertical. Similarly, the bottom rectangle, select the line, select the midpoint and make it vertical. So this makes a symmetric. Now select these two lines, make it equal. Now select the outer line and center line, place it here so that it will give the end-to-end distance from the center. So this is the best practice if you are creating any component. See, I am going to create with a revolve feature. So whenever we create any revolve feature, we have to mention dimension in this way. That is the best practice. So it will give the full length of the revolve feature. So this is outer dia. So this value is 60. Now we have to mention the bow dia. It is 35. So we have to move it upward. So these three parameters mostly we consider 25 width and outer dia of the outer ring and bow dia of the inner ring. These three are very much important. Now I am going to create this circle. It has to be at the center exactly. So draw a center line connecting the two midpoints of this rectangle. And draw a circle from the center. So this is 14. So this sketch is ready now. Go to view option, unhide all types. Now we have to take a new SolidWorks part file. So create some feature. So this is for reference. Save this, and now we have to come back to the assembly. Now in assembly, insert this outer ring. Just simply place it here. Make it float. Now select this front plane of the assembly and component front plane. Give the mating condition. Say OK. Top plane and top plane. Right plane and right plane. Now just go to edit mode of this part. Either we can right click and select, or we can straight away select this component and click here, left side, this edit component. Now delete this reference feature and sketch. Select the right plane of this component. Select a new sketch. Select the convert entities. Select this edge, this edge, this edge, and this circle. So we have to select the top rectangle and this circle and say OK. Select the trim entity. Say OK. Select this edge, convert entity, and select this line and convert to construction. Now go to feature, revolve. Say OK. Now when we go to this component, see this component is created. And we can apply chamfer on this component. So 1.5, selecting both the edges. See, this is an independent feature. Either we can apply chamfer in the part file or assembly mode. So we can modify anywhere. So the outer ring is created now. Come out of the edit mode. Now take one more new file. So I am going to create this inner ring. So I have taken the new SolidWorks part file. Here also select the front plane, go to sketch, create a circle, and create a feature. So this is just for reference. Save this file, go to assembly. Now insert this component. Inner ring. See, why do I create this reference component? It's easy to identify during giving constraining of meeting conditions and checking the orientation. See here. So we can identify the mistake immediately. Front plane, top plane with top plane, and right plane with right plane. Now select this component, go to edit mode, So now I am editing the inner ring. So I have deleted the sketch. See, if this component is causing the disturbance, then we can hide it. Simply hide this component. Now select this right plane, select a sketch, keep it normal. Now convert entities. Say OK. Now trim entity. Now say OK. See, this sketch is created. Select this sketch, go to feature and revolve. See, here we have to create the center line. Select this line, convert entity, and once again select this line and make it construction. Go to revolve. Say OK. See, this component is created. Come out of this edit mode. So I am going to open this inner ring. So this is created. See, we are deriving all the components 3D model from simple sketch. So this will be helpful when we are designing any new component or new bearing with the new parameters. This will be helpful, and it is also helpful when we make configurations of the bearing. Now I am going to create this ball. So I am going to hide this inner ring. So we have to take a new file. Here also select a sketch. Simply create an extruded boss. Now go to the assembly. Similarly, we have to assemble this component. So mating condition with the front plane. Top plane with top plane. Right side with right side. So the component is constrained now. Now select this component, edit component, and we have to delete the reference. Now select the component right plane, select the sketch, select the circle, convert entity, and this line convert entity. Simply pull this point downward and this one upward. Now select the trim feature. So it's easy with the power trim. Now go to feature, select revolve. Select this line. Now I am going to hide all types. See, now we can see inner ring and outer ring, and this ball is created now. Now I am going to create a pattern. So for pattern we should have center line. So we have to select the temporary axis. Go to circular component pattern, select this imaginary axis, component, select this ball, see we have to select the equally spaced and select 6. Now I am going to hide all types. See here, I'll keep it in transparent mode. See, inner ring, outer ring and ball, all the 3 components are created. Now I am going to create this retainer. Sometimes it is called as cage. So I am going to create with 2 different methods. One is with shell feature and other with surface. So I have taken a new SolidWorks part file. Here we have to create a reference feature. Simply draw a circle in the front plane. Create extrude. Save this file. Go to assembly. Select front plane with front plane. So we have to give the meeting conditions. So like we did for other components. So it is constrained now. Now delete this feature. So I have created a sketch in the front plane. I can use this. So to avoid disturbances, we can hide these components. We have to show the sketch even in front plane. Select the sphere, convert entity, make it construction. So I am not able to select this center line, so I am hiding this sketch. Now move this circle to the center point. So make it coincide and select this line, make it construction. Now select this line, go to offset entity, both the side, bidirectional of 2 mm. So the one reference sketch is created now. Now I am going to create one more reference sketch in the front plane. Go to sketch, select this edge of the sphere and convert entity. 2 sketches. Now I am going to the retainer part file. So here we have to show. So 2 sketches are created in the front plane. Now I am going to create simple extrude. Select the front plane, go to sketch, select this edge, convert entity, select this sketch, convert entity, go to feature, flip the direction. So I am taking 20 mm. It should be more than the dia of the ball. Now once again select the front plane, select a sketch, select this circle, convert entity, so draw a line joining these 2 points. Go to trim, select power trim and delete one side. Now go to feature, revolve cut, select this line, say OK. Now hide all type. So this is created now. Now we have to pattern this. Select this extruded cut, go to circular pattern, select this axis. So I have taken as a 6 instances. Now hide all types. So this is created now. Now simply we have to go to shell feature. So before that we have to create a fillets. Just create at initial point. So I am taking as a 2 mm. Say OK. Now add this fillet in the circular pattern. See, this is created. Now apply the shell feature. Select this face, inner and outer face, and select this flat. Here you have to give 1 mm. See, this retainer is created now. So let's see in the assembly. Come out of the edit mode, outer ring and inner ring. So I am going to hide this outer ring. We can see the retainer. It is exactly matching this ball. We can provide the clearance if you want. So since it is an initial design, we can give exact dimensions. See. So I am going to create the same component with a different method. Now I am going to create with the surface. So I am going to use the same sketch for creating that component. Select the front plane, go to sketch, select this circle, convert entity, inner circle and this circle. All the 3 circles we have to convert into entities. Now select the trim tool, use for power trim. So we have to leave only one arc. Here we can select this and this circle, make it co-radial. So now it is constrained. Take a center line, draw from the origin to this point. Now we are going to surface module. Select revolve. Here we have to give 180 initially. Keep it in top view. So it is exactly creating the outer side. So now I am making 200. See, this arrow is moving inside. It is extended. We have to extend the other side also. So now I am making 20. So it is extended. Because I want to trim this surface. That's why I am extending. See, this is created now. Now select the front plane. Go to sketch, keep it normal. Select this outer circle, inner circle, convert entity. Go to surface, create a planar surface. Say OK. See, two surfaces are created now. Now hide the sketches. I want to make this pattern, so I need a axis. So select top plane and right plane. Select axis. Now I am going to create circular pattern. So here we have to select bodies. Select this revolve feature. We have to be very careful while selecting this feature. So we have to select from this surface bodies and select this axis. So I've taken 6 of equal distance. Now I'm going to trim these surfaces. Here, instead of standard, we have to select a mutual and select this face, and we have to select each and every pattern of the surface. Now surfaces to keep, we have to select this surface and the revolve surface. So we have to select everywhere. See, highlighted in yellow color shade are going to remove. See here. So we have to go with mutual surface and keep selection. Say OK. See here. This component is created now. Now we have to apply fillets. Here we have to check whether it's a single surface or not. It is a single surface. Otherwise we have to knit surfaces. Now select the fillet. So it's based on the thickness we have to apply the fillets. So here I am going to take 1 mm. So fillets I am going to take 2 mm. So it should be double the thickness. See here. Now I am going to add thickness to this. One mm. So direction we have to verify. So I'm going to apply outside the dimension. So I have to select this. See here. So this is the second method. Now I am going to create holes on this face. Select this face, go to sketch, keep it normal. Keep it in wireframe. So this is exactly the center. Now draw one more center line. So we have to make sure that these two are collinear. Now take a circle. So it's 1 mm. Select extruded cut. Keep it in shaded form. So it's going to remove the material. Now we have to apply the circular pattern. So automatically it has selected the cut extrude. So we have to select the revolving axis. So it is automatically taken 6 instances. See, this is created now. Now we have to go to the assembly. See here, this retainer is created now. Now we have to assemble one more retainer. So instead of assembling this, simply we can select this retainer and select mirror component. Here we have to select the front plane and say OK. See, it is automatically created now. See, we have created all the components just using this reference sketch. So this method is useful for new product development or reverse engineering. Now I am going to assemble retainer. In toolbox, we have to select the DIN. Here we have to select the pins, rivet, DIN 660. We have to select, we have just move inside the graphical window. So it will ask for the options. Here we have to select 4 length, size 1, and gap should be 2. The gap is nothing but the thickness of these 2 retainers. So it is 1 plus 1 2 mm. Say OK. Now we have to assemble this retainer. So I'm going to delete other one. Select this face, go to meeting condition. Select this face. And this face. Say OK. Say this is assembled now. Now we can use imaginary axis to pattern this. So here we can hide these sketches now. Now select this rivet, go to circular pattern. It is already selected. Now we have to select the imaginary axis. Here we have to take 6 instances. Now we can hide all types. So it is assembled at each hole. Now unhide this outer ring. So this is how we can create a simple bearing with top-down approach. So these are the retainers. So I am going to hide this inner ring. See, this is the assembly. So this is a brief about deep groove ball bearing design with top-down approach. Thank you for watching.